Hello everyone. I am going to show you a tutorial about the begin example in TRNSYS. Okay, I'm not an expert. I just happened to start studying TRNSYS due to a project I had, and I was searching material online and I couldn't find any. So I decided, as I'm going through the documentation and as I'm learning, to make some videos to help other people get started easier. This way I can also get feedback and get corrected on things I have misunderstood or misconcepted. So what is TRNSYS? TRNSYS simulates actual components as a black box. The first, we have to know what is a black box. Let's take it this way. In thermodynamics and physics, if we have to study each molecule of a system, we have to calculate billions and trillions of them. So we have to calculate the energy, the exact spot that it is, the exact velocity, the direction, and many other data. So this is not efficient, and we don't actually need all that because we're studying macroscopically the world, at least in our examples. So what we do is just take, let's say for example we have this component. I'm going to explain everything in a little bit. This is a solar thermocollector. Water comes in, it heats up due to the sun, and then the hot water goes and we use it to our house and blah blah blah. So in the heating process, many things happen, and we have to calculate many things if we want to be 100% accurate. But unfortunately, in fluids, it's not so easy, and it's very time consuming, and the calculations are very complicated. So what we do is implement the black box model, which helps us have the same input as we measure the input, we measure the output, and then we try to fix the model to fit in this input and this output. So this is what a black box model is you have the input, you have the output, and you have to try to build the between in a very simple way so it can run fast, it's efficient, and it's very easy to understand. Although I'm telling you what happens inside the black box, it's not the actual thing happening. It's just mathematical equations helping us just calculating and simulating easier. And of course we accept that these models are accurate enough. So anyway, this is the TRNSYS interface. You go here in the open and TRNSYS, where you have installed it in the examples, in the begin example, and you open it. I have already opened it, so it's here. So you can find this in the documentation, but I thought it's better to have a video so you can follow it easier and just get started with it, and then if you want to just read in more detail, then look at the documentation. So we see all these things, but they are very confusing and very scary at the beginning. This is a simple example. So what we need, what's the general idea of this example, is that we want to have warm water for our house. So in order to do that, we take this solar collector. What it does, it receives energy from the sun and heats the water. So we need water. Where do we get it from? We get it from this pump. This pump takes the cold water from a source and pumps it through the solar collector. Then, due to the sun, we have the warm water which goes out, and then we have warm water. Just forget about that, because this is an auxiliary heating, auxiliary energy. What auxiliary is, it's just a backup system. If we don't have enough sun, or if anything happens, or if it's not enough, then this backup heating system activates, and we are sure that we're going to have warm water in our house. So these are these three main components. This is the pump that pumps the water, this is the solar thermal collector, and this is the auxiliary heating. This is the load profile. What is it? It just tells us how much water, how much, which time of the day it's going to work. You also can see inside these boxes by double clicking them. We see it on the in a bit. And what these arrows are the connections between them. This is the weather data. This is for Ouagadougou. Okay, and it has information about radiation, dry bulb temperature, ambient temperature, or humidity, wind velocity, atmospheric pressure, and all this kind of stuff. Maybe there are too many, but we need some of them definitely to know how much radiation and how much warm water can we have in some days. Okay, what else? This is an integrator. This receives all the results and integrates them, and finally put them into a printer. What is a printer? It's just by putting this component, we just create a file where after the simulation we have all the data as in an Excel sheet, but here we have in a text file. So they list like in the first second we did the simulation, how much was the heat, how much was the temperature of the feed water, how much was the temperature outside the solar thermal collector, and all that kind of stuff. We're going to see the results of that in a minute. And this is an online plotter, or just a plotter. What it does, it just makes a plot. Simply as that. So, okay, I'm going to run the example and then see more stuff. This is the run. This is a little man running. I guess this is quite successful. Yeah, sorry for my computer, it's a bit slow. I don't know what happens. Okay. Click no here to just continue seeing this plot. Okay, what we have, it's kind of scary in the beginning. So we have this, the T output of the pump, the output temperature from the pump is actually feeding water, because so if we see the red one is always still, it's at 20 degrees. This is the output from the collector, it's the blue line. You can also click on the ones you don't want to see and just have them isolated. So temperature of the pump, temperature of the collector throughout the day, and this is an hour the simulation, and this is the output from the auxiliary heating. This, we said, is the heating we use when we don't have enough from the solar collector. And this is the heat output from the collector and the heat output of the auxiliary heating. So in this plot, just to use space more wisely, we have two graphs in two different axes. We have different things. On this one we have temperature, and on this one we have the heat transfer rate. So don't confuse in any way this heat transfer with the temperature. It has nothing to do with it. It just saves us some space. Okay, let's minimize that and come back to this one. So what we had here was that, oh yeah, okay, let's explain these lines first. What are these lines? I could definitely understand this one, like water from the pump, it comes here in the solar collector, and then if this water is not hot enough, then it goes through the auxiliary heating, which works, and then we heat our house. But we see that here we have some other arrows. We have this one and this one. How is it possible water to go to a plotter? This is the confusion that you may have, or at least I had it. This is just a connection. It gives the plotter the value So taking an arrow from this one to this one, from the pump to the plotter, we just make the connection. We just say to the plotter, okay, I want in the plot to show me the to simulate me the outlet fluid temperature of the pump, which we saw that it was continuous and it was 20. Okay, we close it. So not all the arrows have the same thing. Like this is nothing, this is just for information, while this is also, we can picture it in our mind as water. And it also has mass flows of water and all these other stuff which are very useful. And it also happens the same with other things, like this is just input data that we have to have in our solid collector. This is also data that we have to plot from the solid collector, and we just plot them here. So let's see this connection. So we see here we have connected the outlet temperature with one variable in this plot, the output of the collector, as we saw, and then the useful energy gain, the heat output of the collector, which is the Q of the collector. So we just tell this plotter by that connection that we did, by this connection here, by this, just show me these outputs as well. You can put, I think, until 10 values. Okay, and all the same with these things. So in order to not be confused, I'm gonna take and draw these lines that they are water. So what we do is right click on the link, and then this menu comes up, and we go to properties, then to line. I guess I'm going to do this red because it's the hot water. Just tap the line, just whatever you need, just to visualize it better for you. Okay, this is the pump. The pump pumps, as we said, cold water, so we're going to make this line blue. This is just for visualization and just for us to understand better. Okay, this is a very simple example, and as soon as you get used to TRNSYS, then you're going to really understand you won't need these. But as soon as the project is getting larger and larger, I think these are very helpful. Okay, so as we said, we want on this online plotter to see some values simulated throughout the simulating time. As we saw on our plot, we have, let's put all of them here. The cold water is, let me put them all off and then come again here. Okay, this is the red line. This is the cold water from the pump. This is the water always the temperature, of course, the water temperature due to the solid collector, and then this is the water temperature due to the auxiliary heating. As we can, what you can do with the graph is also enlarge this by just clicking, and then this is in a better analysis. And then if you want to see, for example, some specific, let's say on this axis, you just have to press shift and then move the mouse, and then as you see, the values here change. So shift and then move the mouse, and as you see, for example, at 130,670 time, we have these values of the temperatures. Yeah, this is the heat gains of the collector from the sun, and this is the heat that we have to that we get from the auxiliary heating. Okay, so what else do we need to do? Okay, we run the simulation, and we got this graph. So we wanted the graph. You can also change the plot here and make it less. Let's say minimum 10 and highest 80. Okay, and now things are getting very messy. Okay. As we see that we want it until 60 degrees, so this is 60 here. Oops, this is 60. So that's why we need the auxiliary heating sometimes, because we have set the warm for us is 60, so we want 60. So the blue is not enough, it's not reaching 60 unless sometimes. Okay, so we have to operate the auxiliary heating so it can take the water to 60 degrees. So the optimum to understand this calculation, this simulation, is to build it, which we're gonna do it in a further video. For now, I just wanted to go through some really simple stuff together, just to have a really small overview over TRNSYS. So first one is, it's not gonna seem really fancy now, but it's very useful. It's just by pressing F2, we have to click inside. Okay, F2. Okay, when we press it, now I have pressed F2, and it shows us the unit and the type of each component. This is going to be very useful later when you get the errors and you will try to find what happens. As we saw before, that when we press this link, it shows us the features of the variables of the pump and the variables of the plotter. So as we can see here, we have so many. We don't use all of them, the blue ones. We just connect these ones to the solar collectors ones. So, but this is very messy sometimes. So we use this table, and we just have the table connections and not anything else. And this is nice and easy. Okay, as you can see, but let's say we are in a classic, you want to create a new connection, you just press the connection, you just go here to the blue one, you click, and then you go to the other side. Of course it doesn't let me, and yes, you create the new connection. This is for deleting a connection. You can also just click this one and select delete. Okay, and I'm going to show you now connection. It was drive ambient temperature. Okay, this deletes all the connections. This, I don't know why is it not working for me, but it does the same work in the table, but it just does it here. It brings everything up here. And this is link properties which we saw when we made the blue and the red line. Okay, what else? We will see what all these other do, all these points. Okay. So I think this is pretty much it. We have a simulation, we're gonna recreate it, so just to understand what exactly is happening here. And one final thing, as I promised you from the printer that we didn't see anything, we just go to calculate. Don't worry, this is really, I can understand. Okay, calculate, open, external files, out, or just we double click the calculator, we go to the external files, browse or edit, it's the same, we hit edit, and then we get this one, this thing. So what is this? We have simulation every, I think, hour, yeah? So for hour 0, starting point, everything is at 0. After 1 hour, everything again, like the heat, we don't have any heat gains of the collector or any heat from the auxiliary heating. And this way you collect all the data. Why do we have only the heatings and not the temperatures? It's just because we chose to. You can see inside here the parameters, so the input, what it gets. As we see, we have an arrow coming from the data to the printer. It just prints. So the input of this printer is just these two. We can of course change it, and we will show it shortly, how we can put anything we need and take things that we want out. So as you can see also in this link, we have integrated only these two, and by these two we send them to the printer. It's always just a matter of what we want to have in the results and what we don't. Okay, thank you much. I hope I helped you with this first video. On the next video I'm going to show you how to recreate this example component by component. Maybe it's way easier this way, and just make all the connections on our own and understand in more detail why we're doing all this stuff. Thank you very much.